Okay, so this is the part of the course a lot of you were looking forward to, or some might be dreading, and that is the coursework. Okay, you need to basically pick a project now. Okay, now we're going to start this slightly earlier than we normally do to give you more opportunity to research for this and actually spend some time working out how you're going to code this. And that's really, really important. The other thing that's really important, especially for my keen programmers, is don't code it yet. Okay, please, please, please do not code it yet. Please listen to what I have to say, listen to how we're going to do it, because ultimately, most of the marks for this coursework do not come from the program itself. It's the write-up and the process you take to actually get to that code. Okay, so you can pick a project now, but you can't code it yet. So what do you need to do? Well, you need to research, design, and develop a program. Now, most of the marks go for the write-up. Okay, so the developing of the program, it is obviously the code, but it's also the testing that goes with it. It's also the process you went through to actually get there, the development log you're going to create to show how you've actually built it, why you did it the way you did it, and those justifications of the why. So for some of you, that might be quite tricky because sometimes your justification is, well, I like that, so that's the way I did it. Unfortunately, that doesn't carry water in A-level. We're going to be kind of using Agile. I say Agile very loosely. We are going to be doing kind of short blocks of coding, and each time you're going to develop it further, add more features, maybe fix any problems that were there, maybe redesign parts of it. So we're going to kind of be loosely following something called the Agile software methodology. We'll learn about Agile later, but that's kind of what we're trying to do. Now, the coursework project itself must follow a certain couple of rules, and the three main ones are this. It must be complex. Now, the word complex, I will go into more detail later, but ultimately what it really means is you have to design your own algorithms, and those algorithms can't be something you can knock up in half an hour. Okay, they need to be something that is difficult. It can't be lots and lots of libraries. Okay, so we can't just like spend most of the time with libraries and hope for the best. But we can use libraries to help us. Okay, they just can't be the focus of the algorithm. It must have a graphical user interface, so it can't be text-based. Okay, so you must design a user interface. It must have validation in it because that's a key part of the mark scheme. And it has to be in one like the big languages. Okay, so for example, like C++, Java, C#, Python. There are other languages will be accepted, but I do have to ask permission from the exam board for you to do that. Can I be really clear at this stage? You must not use things like Unity, Unreal 5, or anything like that. Those are not accepted. They are very, very difficult to get the marks for. If you desperately want to use one of those engines, then I need to go through it very carefully with you, and we need to get permission from the exam board to make sure it actually meets the mark scheme and meets the requirements. Okay. So you are going to create a program ultimately, and you're going to do a write-up. So what do you need to be able to do? Okay, some of these are technical skills, some of these are kind of more personal skills, which I've been harping on about. So you must be able to code in functions. Okay, without functions, design kind of goes a bit pitong, if I'm honest with you. Also, you can't really get the marks on implementation. You are going to be very limited. I forget which band. I think it's either band 1 or band 2 you get stuck in on implementation. So there's two parts of the course which would you would be marked down on for not using functional modularity. You must be able to research, and you must be able to use libraries. Okay. The reason I know I've said before you can't just rely on libraries, but we are going to need libraries half the time, because if I'm using a library to interact with something and then my algorithm processes that information, well, I need to be able to use a library, don't I? Okay, so there are going to be some elements of library. I'll give you an example. I had one student who did a automated guitar tuner as his app. Really cool app, really cool idea. But obviously you need to rely on quite a lot of libraries to essentially be able to read in sound from the microphone. So we'd have to be able to like plug his guitar into it and use that. So there are going to be libraries you will need, and those then link into your albums. So you need to be able to comfortable reading code on the internet, looking at code examples, and not just blindly follow them, actually looking at them and then using their ideas to implement your own code. Okay, now that means practicing lots of mini kind of projects is really, really important now. Okay, so you don't just simply, oh, here's the tutorial, I'll follow the tutorial, oh, brilliant, got an app. No, what you're going to be doing is, I've got an idea. Okay, there's nowhere out there that tells me how to do this. I'm going to work out how to do it myself. Okay, those kind of apps, that kind of idea simulates the coursework, but also means you have to read examples off the internet. You have to kind of like do the hard thinking to get there. So that means you have to be independent, really independent. You have to be consistent. You can't do this all at the end of the year. Okay, it just does not work that way. You need to be plodding along on with it all the time. And you must be communicative. You must talk to me about your coursework because I can support you and help you with this. So it's weighted in 3 sections, AO1, AO2, AO3, okay, as is the entire course. Knowledge facts is nothing on it, okay, and that's because we're not testing the knowledge facts of the course, okay, although we will expect some knowledge in there, obviously, but you don't get marked for it. The application of that knowledge, however, is definitely a big part of it, but ultimately, this is all about designing, programming, evaluating. Ergo, AO3 is really heavily weighted. So 17% of the entire AO3 on the whole course is that, okay? So that means, realistically, that most of this coursework is designing, evaluating, and programming. Let's really kind of deep dive into complex. Now, this is one, you must have a piece of coursework, which you have to research something. And that research needs to be detailed. You must have an algorithm which you have to go away and work out, how on earth am I going to code this? It can't be something that's simply very quickly off the shelf or done by a library. It needs to be something you develop yourself. So, for example, creating a kind of adaptive AI for Connect 4. So Connect 4 AI, that's very well documented, but one where the difficulty maybe changes. Maybe it learns how well you play and changes that difficulty. So you can control how good the AI is. So if you're using Minimax, for example, maybe you have the different levels of Minimax. So just go all the way down the tree, for example. And then it learns from you. So if you play really, really badly, then it makes it easier. And maybe it has easier AIs, like a bit more randomized or things like that. And then as you get better, it gets harder. So that is something I don't think's out there. It could be a cool app to develop. But what I'm getting at is I've taken something that's kind of almost off the shelf, and then I'm doing something with it. Okay. So you must be able to research these things. You must have a significant amount of time. And when I say significant, I think some of you misunderstand me. When I say significant, I don't mean a couple of hours. I mean a couple of months of research. These are hard things to research, okay? They're not going to be simple. There's stuff that you're going to be learning and researching over a period of time, okay? So storing data isn't treated as complex. Now, very few people do this anymore. But if you do store data, then do something with that data, then absolutely that is okay, because there's the algorithm, isn't it? So I'm processing something with that data. The best projects are short projects. And what I mean by that is they're very self-contained. So not like overarching kind of really big ideas. They're very simple. Okay. But they're hard, they're complex, like the guitar tune, for example. Another really good one was students who did a watermark system which would hide a secret message inside an image, and you couldn't see it was there. Okay, so he kind of coded it so it would hide a secret message in binary in the image, and then you'd have to use an app to read it, and it would be just a normal JPEG. You'd be able to share it with anybody, but you wouldn't be able to tell there was a message in there without using this piece of software. So it's really, really cool. There was highly complex algorithms but very self-contained. Another cool example, which is one that I'm going to maybe suggest some people have a go at, is creating their own version of Little Man Computer Simulator, because there's a lot of really cool computer science behind it, but it's also very self-contained. So to get top marks, your projects must be something you can research. Okay, that is really, really important. It's something that you can break down into smaller parts. So it's not just one thing and you code that and it's done, but something you can break down into smaller parts. Something you can apply validation to. That's something people will overlook a lot, but fortunately, there's a lot of marks kind of linked to validation. And even though the exam board are very clear and say, well, if the app doesn't need validation, then, you shouldn't penalise. But the reality is the moderators will, because not everyone thinks the same way, and then it becomes really messy. So it is easier just to play ball with the validation than try and argue the point that validation is not required in this app. It must have a GUI. That's a no. That's non-negotiable. So go for research. There are different areas that you can research. Existing applications is one of them. So there must be something similar on the market that you can look at, that you can gain inspiration from, that you can talk about, you can analyze, you can say what's good and what's bad about it. But the bulk of your research is going to be these algorithms. It's about how are you going to do this, not what's the code for it. Okay, I'll repeat that again. It's how am I going to implement these algorithms, not what's the code for them. All right, that is super important. It's really, really important you understand the difference between designing an algorithm than, well, I'm just going to get some code for this algorithm. So what research is not? So let's say you want to make a Pac-Man game. Okay, now this won't work. Okay, some students have insisted on doing games like this. Unfortunately, it becomes really difficult to get marks on this because you need to start to research the albums yourself. Okay, so rather than I want to make a Pac-Man game, well, here's a tutorial how to make it. Oh, brilliant! I'm done. Done my coursework. Brilliant. I'm going to get full marks. No, you're going to get very few marks. The reason behind that is there's no kind of algorithm there. There's no algorithm you have designed. There's no algorithm you have created yourself. Okay, you've simply just copied the tutorial. Okay, doesn't get any marks. So let's say you were going to an LMC simulator. Okay, I mean there are example simulators out there. You could maybe look at the code and just like to write it yourself, or you can work out how to write a simulator. Okay, how do you write a simple assembler? So looking at, well, how do I parse text and turn it into something that I can do something with? So parsers become part of the research. And this is kind of where the detail comes into it. So if I was going to do Little Man Computer Simulator, I would need to parse the text, I would need to do syntax analysis, and there's kind of a very well-defined series of steps you'd have to follow. But in order to do that, you have to actually code and implement each step. So you'd have to research things like regular expressions and Backus-Naur form and loads of cool stuff, which means there's loads of scope for research. There's loads of scope for you to do analysis, and there's a real clear kind of series of steps for implementation. There's very clear validation going to be in that app. So you can see it's going to make a much better project. And also, it's very self-contained. We know what LMC is. It's got 12 instructions. Boom, done. It might have 10, I forget. But you get my points. So it must have a graphical user interface. So for example, in Python, you could use tkinter, you could use Pygame, you could use Qt5. You're not allowed command line. If you are thinking about doing a web-based interface, again, ask me first, okay? Because we need to make sure that it's just the interface. It's the app. It is the interface for the app, not the app itself. React and Node.js is allowed, but we have to ask permission because sometimes they don't. There's some aspects of that kind of stuff that can be auto-generated, so we've got to be slightly careful with that. So it needs to be a problem we can break down. It needs to be a problem we can break down into modules, and we need to be able to turn those modules into functions and classes. Okay, that's a core skill anyway, but also it means that I can take parts of it and implement parts at a time. okay, which is another big reason why we do it. So games is probably what a lot of people will want to do. Okay, it's natural; it happens every year. The problem with games is that they are tricky to make, and you need to be really careful, because if I made Pac-Man, for example, well, it's so well defined out there, so many tutorials out there. What is my game going to do differently? Okay, what am I actually researching in Pac-Man? Because the goal of this project is to develop an algorithm. What algorithm am I developing with Pac-Man? Okay, it might be that we're having a more advanced AI behind the scenes for the ghosts, for example. Maybe they're using Dijkstra's shortest path to work their way around. I don't know. But there has to be that kind of thought process behind it. So we can't just simply make a game. We need to make a game with a complex algorithm. Okay. Also, and this is really important, is please don't, if you do definitely want to make a game, don't make a game that is something with levels, something where you have to kind of design the levels yourself and maybe like have NPCs and all that kind of nonsense, because you have to make it. And you don't want to spend all your time developing a story and levels and designing all this kind of stuff, when actually your focus should be on the algorithms and things like that. So things which would work better as a game are ones where you are going to implement something. So, for example, one that worked really well in a previous year was a student who created like a roguelike adventure, and his algorithms were not like moving around shooting stuff in the maze, but actually generating the maze. His focus was the maze. Okay, that was his algorithm. That's what he had to research. That's what he had to do stuff with. So he had a complex algorithm inside a game that he was implementing. Okay, so that's the key. If you are going to do a game, I'm going to be a bit strict this year. I'm going to force you to tell me what the complex thing is. I'm going to force you to tell me what research you've done on it, so you can tell me you've got some ideas of what you're going to do. Okay, you can't be simply going, I'm going to make missile command, sir. Okay, no, you're not. Okay, what is it complex about? What's going to be the complexity in missile commands? That's the question I'm going to be asking you. So these are some games that have worked well in the past because they've got complex algorithm behind the scenes. So the snake game one, that is, I mean, it's not going to get you an A grade. I'm going to be openly honest with you, but it is simpler game. So if you're happy with a D or a C, it will work. Now Flappy Bird, it's not complicated at all in the slightest. It won't get you the marks. Full stop. End of story. But an algorithm behind the scenes which is generating backgrounds. Okay, the Flappy Bird bit is incidental. Okay, it's the background generation becomes the complexity. Okay, so having kind of parallax scrolling with multiple midpoint displacement algorithms generating kind of different mountains, things like that. Now that is an algorithm. Okay, that is the complexity. Okay, so the complexity there is not the game; it's the background being generated. Asteroids with dynamic difficulty. Okay, anything dynamic difficulty works quite nicely because you have to work out, well, how am I going to measure difficulty? How do I know if they played well or not played well? How am I going to measure that? So straight away you got those kind of questions and ideas and things you can kind of analyze and work out. Excuse me. Pac-Man with personalized ghost personalities. Now they do have personalities in the real game Pac-Man, but you can start to kind of delve into that. So what algorithms are they going to be using? How's it going to be different to the real thing? Are they going to have special powers, for example? Can they go through walls once every now and then, stuff like that? I don't know. Top-down driving games can work very well. I'm going to say that's a less good project nowadays due to there's lots of tutorials out there for that kind of thing, and it does require you to understand physics quite a lot. So that can be quite tricky. Rogue style games where the level is generated. Anything that's generating levels is always good. There's tons of scope there. Digger games, believe it or not, they're actually quite difficulty. They have quite high level difficulty because you have to work out, well, how do I not only deal with sprites, but actually have sprites which get destroyed, and manipulating images in order to have maths in there and things like that. So that's quite cool. Barman's quite cool as well because you've got those destructible bricks, and then you've got the kind of flame shooting out. Those require algorithms behind the scenes. Tetris, easy. Tetris AI, difficult. Okay, so having an AI which plays Tetris. Again, Connect 4 with those kind of dynamic levels of AI also works well. The games were iffy. Mini golf was really iffy, really iffy. And the reason it was iffy is because most of the students' time was spent on the physics behind the scenes. And it was just a big maths problem rather than a big computer science problem. 3D tank game. This was a Unity game that a student made, and they got to the third prototype. And I said to him, "Where's your algorithm? You know, we spent so much last time playing with Unity. I think it was Unity they made it in. They had this beautiful like 3D tank game, but most of it was drag and drop. Most of it was very simple coding, and he had to do a fourth prototype, and he had to add another complexity in the end. He ended up doing AI for the enemy tanks and had some enemy tanks in there you could shoot rather than having it 2-player. Quiz games, too simple. Simple game with directional bullets, too simple. Pool game, again, iffy because it's complex. It's the physics behind it seems, not necessarily the algorithms. And one student did do a Minecraft clone. They were insane. It was so complicated and so difficult. They got a third of the way through what they wanted to do. It was enough to get the marks, but it was so hard, and they worked so hard on it. One student did do a Zelda game, two actually, tanked massively because, again, it's story-driven, isn't it? So they spent too long on the story and not enough time on the coursework. So, projects which worked well in the past. So Boolean algebra calculator, that's always a good one. Normally at least one person has to go at it each year. There's a lot of really good algorithm behind the scenes and clear validation, clear user interface. They always have their own kind of take on it as well. Maybe generate a kind of map from it, or anything along those lines. Excuse me. Little known computer simulators are good. The invisible watermark. Stock and crypto market simulators do work quite nicely because there's lots of algorithms you can put behind the scenes in that one. Rubik's Cube Solver was really good. Game of Life simulators. There's one student who took that idea and turned it into a COVID one, which was quite poignant at the time. So that was quite fun, actually. I say fun. It was good. CS algorithms visualizer, so one that was visualizing Dijkstra's shortest path and A star and breadth traversals. You've probably seen when we do it in year 13, you'll see these kind of visualizer. A student made one. It's really cool. Poker with AI was really good as well. Had a student did poker with networking. That was difficult. It was good, but it was difficult. So you need to work independently. This is the kind of idea. You'll be getting 2 hours of lesson time when we start doing implementation, and there will be obviously lessons where I'm teaching you how to do things. You will be expected to be doing 2 hours per week at home on this, and that is going to be the consistency. And you have to be independent because I'm not going to be taking it in every week because I can't. Okay, it's not realistic. I can't look at your work and say, well, have you done 2 hours of work on this one? There's no way I can do that. So I'll be looking at it periodically, obviously, marking it, giving you feedback and all that kind of lovely stuff. But what you need to do is make sure you're doing 2 hours per week on it. It's very important you put the time in now. Now, I know it says 2003. I meant to put 2004 on there, but you get the idea. So the biggest issues I have seen in the past are not using independent time. That's the big one, okay? If every single student who has had issues, it's normally down to the fact they didn't do any work or anywhere near enough work at the start of the course. It's as simple as that. And that kind of links into the next point, which is not doing research during analysis. So in analysis, you're supposed to research how you're going to do this. Some people kind of don't do that properly, and as a result, have the foggiest how they're going to design it. And because they can't design it, they can't make it, and can't make it. You can see where that goes, can't you? Picking something they don't understand. that is quite common as well. And that's why I want to take our time in deciding what project you are going to do and making sure that it's something you can do and something you can research and something you can find out about. Not asking for help and also not coding too early. Those are two big issues. Spending too long on the UI. So your first prototype is just making it look pretty. Please don't do that. It really makes a big issue later on. Not commenting your code. Seriously, you must comment your code. Get used to it now. Not adding validation to your coursework, and also not following the mark scheme. Okay, the last point, it makes sense you should do it, but the mark scheme is disgusting. It's horrible. It's not great. It's really hard to read and really hard to understand half the time. So I will be breaking it down for you and explain, well, you must do this, this, and this, get that mark. But you have to listen to that.